Hi guys, today is a product review day. We got a wonderful programmable AC power source. It's from Itech. Itech is sponsoring the equipment and this is the model IT7321 and it has the capacity of 300 volts amperes. Now let's learn about this product. First, let's understand a little bit about it. If I am in Japan, I'm using 100 volts. If I am in America, I'm using 120 most of the countries. If I am in Europe, I'm using 230 volts. So I will take this value, I will divide this value by the voltage I'm using, and I will have the amount of current that I can apply to the device under test from the source. This is important to understand. I have the power button, the local to use the front or the rear functions, shift to use all the second function, whatever is in blue. I have the numeric keypad, the function keys, and the joystick with the up and down, right or left, and the knob to change the values. Let's turn it on. After the self-test, it's very fast to turn on, and I want you to pay attention to this. First, I want you to pay attention to the silence when I'm not talking. About 31 point something, right? Now let's pay attention when I turn on the unit. Yes, it's one of the quietest electronics instruments in my electronics laboratory. I'm impressed with that, about 4 plus decibels from the silence. YouTube is full of reviewers, engineers, technicians complaining about how noisy is their new oscilloscope, their new power supply, even function generators. But this unit, wow, from A to Z, pure quality, well designed, and very silent. Voltage is something that I set up. Current, I do not set the current here. This current is the product of the measurement of the consume from the device under test. And I am able to change the frequency, and I can decrease less than 50 Hz a little bit. I can increase a lot after 50 Hz, just in case I want to make the emulation of a UPS power supply. Some of them they work with 400 Hz, so I can set up even to 500 Hz here. Down I have the watts power factor, what is great to see how good is the volts amperes reactive consume in the device, and with select I can see the volts amperes and the amperes peak. Let's give a voltage to it. Let's say I am in Japan, okay? In the first time I start, I can type directly the amount of voltage. If I want to change it, I will need to press volt. So and I can use the arrows to increase. I can use the keypad. I cannot get 500 volts, but I can get 100. Oops, sorry. Escape. Good that I have escape. 100.5 to give an example, and to assimilate the value I press enter. I can decrease volts, that value, or increase it. I like the knob that doesn't have drift. Each step is one number, so there is no way to miss it. It's great because in another device I always mention if I have drift in the knob. Or I can use those arrows and to move wherever I want to get my value. Enter. So that easy, just volts, give the value of volts you need and press enter. The frequency, same thing. I can use the knob, I can use the arrows, or I can use the keypad. Enter. Ready. It's ready to use. I need to press on to get the output. And there is a light. It's not a strong light. I wish it to be stronger, maybe for next batch of products, but as you can watch here in the camera, I think it's enough. Maybe I'm complaining too much, right? Okay. Now let's say I want to, in this laboratory, I want to make some tests and I need to get some products emulations. So let's do it in this way. I don't want to be punching buttons all the time. So I will select the Japanese voltage. So let me turn it off. The output, I mean. There is no voltage in the output now. I have 100 volts and I will press Shift, is the second function, Save, it's the blue one, in memory 1. Enter. Okay. It was with 50 Hz. Let's say I have to test or design products for America. So in that case, it's 120 volts. Volts, 120. America is 60 Hz. So enter. Now I'm going to change the frequency. I fixed the voltage, frequency, and 60 Hz. Enter. I fix it there, right? Shift, saved, the blue one, in memory 2. Enter. Okay, but also I'm in Europe, and in Europe we use most of the time 230 volts, 50 Hz. So let me fix that value to have it just in the memory, because I have here memories I can use. So volts, 230 volts, enter. Remember, Europe is 50 Hz, so frequency 50 and enter. Now shift, this is the second function, the blue one, save, and I will put it in my memory 3. Enter. Right. Now I want to recall the memory, so I just press recall 1, enter, voila, 100 volts. And on, and I have 100 volts in the output. Let's say I want to test now an European product, so I just turn it off, recall, memory 3, enter, and 230, 50 Hz. An American product, and the same thing. I will just make sure it's off. It's better all the time you make changes, unless you want the product to suffer the changing. We will make a test like that. The correct procedure is turn it off, make the changing, turn it on. If you want to submit the product to the changing to see the reaction, leave it on, right? So now let's go to the American product to test. In that case, is off here, recall 2, enter, 120 volts, 60 Hz. Great, easy to use. Also, it has some more functions. If we check here quickly, shift menu, I have the system, and I can tell the unit if I want power on, power out when I turn it on, if I want the buzzer to make noise or not. I just press enter, and with the arrows you can change to off or on. I will leave it on, enter, and I will keep going. Trigger, for some of the functions I can trigger by the system, I can trigger by the signal or by pressing shift trigger, and to give a shot to the test I'm doing. Communication, this unit comes with a LAN, with a serial communication and USB. And also has a relay control, and I can tell if I want the relay to be open or close contacts. Enter. Now it's closed. Enter. As you see, it's flashing the close. Open contact. I can use it to set up a function where I need to trigger a relay. Did I leave it on? Open, right. So now that's about that session. I can escape and go to config. Configuration, enter. I have the minimum voltage for the unit. In that case, let's say I am interested in to set the units to 85 volts. So enter, 85, enter. The maximum voltage, let's say 240. Let's move on, enter. It has 300 volts, but I am not interested in to reach so much amount. Let's say I want to leave 250 as the maximum voltage. Enter. Let's remember, I have to divide this 300 VE between the voltage I'm using in the test, and that gives me the amount of current available. So the frequency, minimum frequency, enter is 45 Hz. I rather to use most of the time 49.5. But depend of the test, you can down the frequency too. The maximum frequency, this goes to 500 because, as I mentioned, sometimes we have an UPS emulation and UPS is 400 Hz. So that's the reason it led you to go so high. And escape. And this is the IRMS protection. Here I set up the maximum current I have for protection. In that case, I make a limit for the 230 to this amount of current, but if you are using 110, remember, you can use more current than that. All of my tests here is for small devices, and I don't need huge amount of current. Enter. This is the peak. One was the peak protection, and the other is the maximum amount of current I can use. So I'm in the limit here. Also, I have the eye trigger, and this is for the BNC connector I have there behind. I can use it to trigger the system, or as I said, shift trigger, I can trigger it manually here, or I can use that BNC connector as an output synchronization or as an output on to follow up. So give me flexibility for the special test in what to use that connector. We will watch later in another videos about those applications when it comes to time. Now let me escape from all that. The maximum current protection and the dimmer, and this unit can make an emulation of dimmer. And that's good because if you are designing something that works with a dimmer, you can set up the parameters, the minimum and maximums. You can turn your system or it will react to. So instead of in one test to be designing and redesigning the dimmer, you have the dimmer emulation already here. List test, later we will know about it, and the measurement frequencies for low or high. Escape. And the current modes for auto and manual. I leave it in auto. So that's the about configuration. The next one is information. It gives me the model, the version of the BIOS. Oops, sorry, I came out. Shift menu. I am in information. And the next one is the serial number. Now I'm done. So that quickly we learned how to set up the voltage, the frequency, and how to put in memory. Now we are going to make a test with a monitor, and my monitor works. I think it's great. I don't have any complaint of my monitor unless this unit will show me the contrary. There is here a monitor, and the monitor is connected to the unit. Supposedly this monitor should work from 100 volts to 230. Is it true? Let's test it. But first, let's remember, we have here the measurements of the watts and the power factor. And also, I can get the volts, amperes, and the amperes peak. Now 100 volts. And the current consumed is half ampere. Let's go to 220 volts. Aha! There is an issue here. I will never tell my monitor is in a wrong condition until now that I got this unit and I could test it. It works with 220, but making a deep voltage and making the jump to its correct voltage is something that internally generates a peak of current that makes the monitor to fall. And the monitor is not coming on. Now I realize, and you will never know it, too, that the product that I thought was okay, I connected to 220 and works nicely, has an old power supply that needs a review. Let's see if the problem is related with the current peak detection or the voltage dip when the voltage falls down. So because the voltage is 100 volts minimum, I will try to make a test for, let's say, 95, 85 volts. Let's see how is it going. Better say 86. $95, and the monitor is working. 86, I'm expecting to fall, and the monitor is working. Great. The correct step will always be to turn off to make changes. but in my case, I wanted to submit the monitor to the voltage changing and not to receive the new voltage, to assume the voltage changing. So the peak of current of the monitor is very high and was detected by the unit, and the unit shut down. So in that case, I have to check the power supply about the current limits and try to help the monitor to do not get a peak of current. That peak of current, if the monitor allows it, someday will kill it. So we realize how a unit like this is effective for many kind of tests. After the test, I realized my wonderful monitor wasn't good and is a candidate for a catastrophe. I will bet my money that it was right, but IT7321 showed me that my monitor is not in a good shape. I wouldn't know it unless I get this instrument. Thanks Itech for this instrument, because it's the kind of instrument we truly need in designing, in testing, in special testing, service, electronics laboratories, maintenance, to know in which shape our equipment is. And it's easier to troubleshooting and to get preventive maintenance with this kind of instrumentation. This is important. Let's say I have 230 volts and I'm connecting the device under test, and something I don't want to happen is by mistake to increase or decrease the voltage or to touch the wrong button or something like that. It could happen, right? So we have shift, locked, and now whatever happens there, I'm punching the buttons, moving the knob, the keypad is locked. And that's good because it's for our safety to do not make any mistake. To unlock it, just shift, locked again. And now I am changing the voltage. It has functions like sweep, list, and dimmer, and this one I can use it if I am doing normatives tests, electrical normatives like the IEC 6013-4-11 or -14 or -28. It has the simulation for that. Also for special tests, there is an output or input or trigger option behind the unit that I can use to synchronize my design to one specific point of the rising and falling edge of the AC output, or according to monitor the voltage synchronization. I have those options. So that makes this unit useful for electronics designers, test engineers for the pre-compliance and compliance electrical normatives, for the special test electronics laboratories. And now let me tell you why repairing electronics laboratories becomes the big losers if you don't have one unit like that. Because many times we have a client, we did a repairing, and the client came back with the device broke again. How come if we fix it, we will fix it again? And it could happen by third time. Don't expect your client to come by the fourth time. What escape from testing in that case? That the lacking of this unit, you didn't have enough resources to find out if there is a defective power supply, even when we see, we watch, we test, and the thing is working. Power supply could be defective and we can detect it with this unit. About the cost, let me tell you. If you are in electrical normatives compliance, the test is about $15,000. If you are in special tests for debugging, for new designs, new products introductions, analysis, for special tests, the charging of the service is about $1,500. For electrical normatives in pre-compliance, the test is about $1,000. So now you realize that the price of this unit is paid in the first or less than first or in the second time you use it. So it's a great investment. In the case of the guys who are in repairing, maybe you will have to make several repairings to recover the investment of this unit, but at least you will not get the client back for something that escaped to your eyes and your testing and your capacity and your electronics laboratory test gear capacity, because with this unit you can find a defect power supply very easy. Thanks Itech for the IT7321. We really appreciate it. We are going to make another videos, application videos with this unit. To all of you, I invite you to visit Itech's webpage. The link is down below, and about this unit too. Thanks by watching the video. See you next time. Do not forget to give a like to the product. It deserves it. Thanks again.